Okay, Common Core Algebra 2. So here we are for 5.2 Part 2. We're still in Factoring Polynomials, and in fact, I believe I called this one Special Cases. So we're still talking about factoring, but we're going to look at special cases. So there are 4 special cases we're going to look at. First one, difference of squares, and then we're going to look at something called the perfect square trinomial, and then finally the last two, the sum of cubes and the difference of cubes. And this we actually already did in class. Okay, so we're going to finish that up the next section in class after we've talked about our special cases. Okay, so first special case, difference of squares. Now that's when we have it in this form, a squared minus b squared, and it's really important that we have a subtraction there. That is our difference. Anytime it is a squared minus b squared, it's always going to end up just being and factoring into a minus b and a plus b. An example here, you'll notice that we have this whole term is our a squared and this whole term is our b squared. So you can figure out a by square rooting everything. So the square root of 49 is 7 and the square root of x is x. The square root of 64, so we're going to do the same thing with b, the square root of 64 is 8. Now if you got decimals for one of those, then in that case it would not be a difference of squares, and therefore we couldn't factor it using the difference of squares method. But since a and b exist as such, we're just going to write them as 7x minus 8, so that's the a minus b piece, and then 7x plus 8, that is the a plus b piece. And in reality, again, it doesn't matter if we switch these. We could have had 7x plus 8 and 7x minus 8. Either way, you're going to get the same answer. Okay, so that's difference of squares. The next one is what is called a perfect squares trinomial. So that's when we have it in the form a squared plus 2ab plus b squared. And now, again, these two pieces being the most important, that third one is just going to check it for you. And we're going to get a plus b times a plus b. So it's called a perfect square trinomial because these two are the same, and in fact we could rewrite it as a plus b squared. Okay, we're going to do the same kind of process. We want to look if I square root my a and my b terms, my a squared and my b squared terms. In this case I'm going to get 2x, and in this case I'm going to get 3. And we should check, what does 2ab equal? That equals 2 times 2x for a times 3 for b, and if we combine all those we end up with a 12x. So that actually just tells us that we're good. This is in fact a perfect square trinomial. You have to do this piece because otherwise if that was any other number other than 12x, this wouldn't actually work that way. And now that we know a and b and we've checked our work, we can plug it in. So we're going to have 2x plus 3 for a plus b and 2x plus 3 again for a plus b. And in fact, a more succinct or shorter way to write it would be 2x plus 3 and squared, because we have the same thing times itself. Okay, this is a great way to write the answer. Alright, so the last two that we have are going to have to do with cubes, meaning we have a cubed and b cubed. The first one, a difference of cubes, that has to do with this subtraction. And so it's when two perfect cubes are subtracted. So a cubed and b cubed. We need to figure out what is a, what is b. And then we're going to plug them into what looks like a somewhat ugly formula, but it's not too bad. A minus b in parentheses, we have a binomial times a trinomial. A squared plus ab plus b squared. Okay, same idea. Now, instead of square rooting though, we're going to do that cube rooting thing we had. And if we cube root 27, that tells us that a is 3 and the cube root of x cubed is x. So we're going to get 3x. If we cube root 125, we end up with b is 5. So we need to plug into this formula. The a minus b piece isn't too bad. We can just say 3x minus 5. That is a minus b. The tricky part then is squaring a, which means we need to square both of these pieces. So squaring 3 gives us 9 and squaring x gives us x squared. So that first term is 9x squared plus a times b. So 3x times 5 gives us 15x, and then b squared. In this case it's not too bad because we only have 5. b squared is 25. So we're going to write it as plus 25. And that whole thing, that binomial times that trinomial, would give you your factored form of this special case of difference of cubes. And the next one then is very similar to it. It's a sum of cubes. So this time we just have two perfect cubes that are combined. And your formula for this one, for some reason I don't have here, we have a cubed plus b cubed. It looks very similar to the last one except for we change some signs. We are going to end up with a plus b and then a squared, so it's plus instead of minus this time, Here it's minus instead of plus, but everything else is the same. So the only thing that happened is we swapped these two signs that we did in the last one. Okay, so we're going to do the same thing. We need to cube root both of those, which in this case now a is just x and b is 2. If we plug it in, then a plus b is going to be x plus 2. A squared is going to leave us with x squared minus ab. So we don't want to write it as x2. Remember, we wanted to write the coefficient first. I'm going to rearrange that to give us 2x. And then b squared, so 2 squared is plus 4. And this sum of two cubes would be rewritten like that. Okay, and that is it for our sum of two cubes. Those are our 4 special cases. So we have done a difference of squares, a perfect square trinomial, and then a sum and difference of cubes. And like I said, we're going to go over this in class tomorrow. We've got about 2/3 done already. We just need that bottom middle section so that we can have our special cases as well. All right, see you next time, guys.